Hello, good morning, guys. So in the last class, we discussed about OSPF. We saw about OSPF features. We saw OSPF packet types. Okay. Then we saw about your OSPF neighbor states. Then in OSPF, we have a DR-BDR concept. Okay. And we saw about LSA and LSDB. Okay. So in the packet types, we discussed about 5 types of packets. One is the hello packet, then database description packet. Then we discussed about LSR, LSU, and LSAC. These are the 5 packet types. Okay. In the neighbor states, we saw first is the down state. Then we have the init state. After that, we have a two-way state, X start. We have exchange. Then we have loading. And the final state is put. In the two-way state, your DR-BDR action takes place. And in the X start state, your master and slave action takes place. Okay. Then in the DR-BDR election, we saw that for DR election, we have certain criteria. Right. First is the DR-BDR highest priority. The router with the highest priority is going to be the DR. And if the priority is equal, then the router with the highest router ID, it is going to be the DR. And about the BDR, the second highest priority and second highest router ID. So this was about DR and BDR. We saw that your DR and BDR, they listen on the address 224.0.0.5 as well as 224.0.0.6. And your DR others means the routers which are not DR, not BDR, they listen only to the address 224.0.0.5. Okay. Then if there is a change on DR other, it is going to send an update to the DR and BDR only on the address 224.0.0.6. And then again, when your DR is available, your BDR is going to remain silent and your DR is going to update the entire network. And all the routers in the network, they are going to accept the information delivered by your DR. Okay. Then we saw about LSA and LSDB concept. So there are total 7 types of LSAs in your OSPF. But when we are considering about single area, OSPF single area, then only 2 types of LSAs are there. One is the type 1, that is your router LSA. And second is the type 2, your network LSA. Okay. Your router LSA, it is generated by all the routers in your area. It is generated by all the routers in an area. And your network LSA, it is generated by the DR. Okay. So, and both these, they belong to the single area, means these 2 types of LSAs, they will flooded in the same area only. They will not travel out of the area. Okay. So this was the information we discussed yesterday. Today, we'll be starting with the ACL. Next topic is the ACL. So what is ACL? ACL stands for Access Control List. Okay. So with the help of Access Control List, with the help of ACL, what we are going to do, we are going to filter the network traffic. Okay. We are going to decide which type of traffic your router is going to allow and which type of traffic your router is not going to allow. So your ACL is used to filter your network traffic based on the rules you configure in the ACL. Okay. Basically, the name itself suggests access control, means controlling the access. Okay. So let's see the introduction about the ACL, then we'll see how to configure the ACL. So what is ACL? ACL is a set of rules defined for controlling network traffic and reducing network attacks. Okay. ACL are used to filter the traffic based on the set of rules defined for incoming and outgoing of the network. Means on this router, let's say this is your router. So on this router, you are going to define certain rules that if a particular type of traffic is coming, if it is coming from a particular source or particular service, then allow that particular traffic, and remaining traffic, just deny that. Means either you can allow particular type of traffic and block rest of the traffic, or you can block particular traffic and allow rest of the traffic. You have the choice. Okay. So it is completely based on the rules you define in the router. Okay. The rules will be created by us, the network admins. We are going to create the rules that what type of traffic we are going to allow and what type of traffic we are not going to allow. For example, let's say you are having a web server. In your company, you are having a server. Right. Now the server should be accessible by everyone in the company. But if you want that no one should know that the server is available or not, so you can block the ping traffic. So no one can ping the server. So if there is a ping traffic going to the server, your router is going to drop instantly. It is not going to forward the ping traffic to the server. But if you are accessing the website, you will be able to access. So you will have connectivity with the server, you will be able to access the server, but you will not be able to ping. So like this, you can filter the type of traffic, because let's say if I'm able to ping, so I can know that, okay, I have the connectivity with the server. I can check with the help of IP address, with the help of pinging, I can check the connectivity, right? But I want that they should not be able to know whether the server is reachable or not. Okay. So for this purpose, we can block particular type of traffic. Is it clear? Now your ACL, it can be applied in two directions, for the incoming traffic and for the outgoing traffic. Because in the router, there is only two possibility, whether the traffic will be incoming or outgoing. So if you apply the ACL for incoming traffic, this will be inbound. And if you apply the ACL for outgoing traffic, that will be outbound. Means these are the two things you need to understand: inbound and outbound. Inbound is for incoming traffic, outbound is for outgoing traffic. Okay. So if you apply inbound on an interface, that particular interface will become inbound interface. And if you are applying for outgoing interface, the interface through which your data is outgoing, your traffic is outgoing, that interface will become outgoing interface. Okay. So once the access list is built, then it should be applied in inbound or outbound. So inbound for incoming, outbound for outgoing. If you talk about your inbound interface, the interface through which router receives the traffic, the interface at which router is receiving the traffic, or the traffic is incoming at the router, that is your inbound, and the traffic will be known as incoming traffic. Similarly, for outbound interface, the interface through which router transmits the traffic, routers send the traffic out, that will be your outbound interface. And that particular type of traffic will be known as your outgoing traffic. Is it clear? Okay. Now we have two types of ACL. One is the standard ACL and second is the extended ACL. Okay. These are the two types of ACL we have. To define these ACL, to define the rules in the ACL, we have two methods. One is the named method and one is the numbered method. So these methods are applicable for both standard as well as extended. Now, what are the differences in your standard and extended is, the main difference is your standard ACL, it is just blocking on the basis of source IP address. Okay. It is blocking on the basis of source IP address. It will not check anything else. If a particular traffic is coming from a particular source, it is going to deny or permit according to the rules. Okay. For example, this is a network. We are having a router. Then this side, so let me just create two networks. So this is your network 1. This is your network 2. Correct. And this is your PC1. This is your PC2, PC3, PC4. Now you want that your PC1 should not be able to communicate with these two systems. So who will be the source? PC1. So you just configure a ACL in your router that if any traffic is coming from PC1, just block that traffic. So router is going to instantly drop that traffic, and your PC1 will not be able to communicate with PC3 and PC4. But your PC2 will be able to communicate. Why? Because the rule has been defined only for PC1. Okay. So when I'm saying if any traffic is there from PC1, then block it. So what does it mean? Means it is going to block the entire traffic. I cannot say, with the help of this standard ACL, I cannot say that when traffic is going from PC1 to PC3, then only block. If PC1 wants to communicate with PC4, do not block. This facility I do not have in my standard ACL. Why? Because it is just checking the source IP address. So we cannot specify the destination. In case of standard ACL, we cannot specify the destination. So if you cannot provide the destination, means entire traffic from PC1 will be dropped. Correct? Okay. Then in case of extended ACL, your extended ACL can filter on the basis of, first thing, source IP address. Then it can filter on the basis of destination IP address. It can block on the basis of port number or protocol. Okay. So this provides you more control over your network. Means you can block a particular type of traffic. The example we were talking that you should be able to access the web server, but you should not be able to ping. That will happen with the help of extended ACL, because we will be blocking a particular protocol, the ICMP echo. Okay, ICMP protocol will be blocking, but your HTTP, HTTPS, all those protocols, they will remain continued. They will have the communication. Is it okay? Clear? Now, if you see the differences between your standard and extended ACL, so let's do one thing. First, we'll go for the practical and then we'll compare these differences. Okay. So first of all, I'll show you the commands. What are the commands we need to specify the ACL? So we have two types of ACL. One is the standard ACL and one is the extended ACL. Okay. These are the two types of ACL. Your standard ACL, block or filter on the basis of source IP address only. While your extended ACL filter on the basis of source IP, destination IP, port number, and protocol. Okay. Now to define these, we have two methods. One is the numbered method and one is the named method. Okay. So first of all, I'll start with standard numbered ACL. Yes, please. So I'll say numbered standard ACL. So in the numbered method, you are going to use a number to define that it is standard ACL or extended ACL. In the command, you're going to define a number to specify whether it is a standard ACL or extended ACL. So for standard ACL, the number is from 1 to 99. Any number you use, that will be your standard ACL. Okay. And from 1300 to 1999, this is your standard ACL. Okay. These are the numbers you use. So this is the standard range, normal range, and this is the extended range. Okay. Means these many standard ACLs you can create. Clear? And in one ACL, you can have multiple rules because it is access control list. And in a list, there can be multiple entries. Okay. So how do you define a numbered standard ACL? See, in the global configuration mode, you're going to say access-list. Then you are going to give the ACL number. Okay. So in your packet tracer, only 1 to 99 is going to support. In your packet tracer, only 1 to 99 is going to support. If you want the higher range, extended range also, you'll have to use either GNS3 or Evenge. In your CCNP, you can use that. Okay. But this is just a number to define the ACL, whether it is standard ACL or extended ACL. Then you're going to say whether you want to permit the traffic or deny the traffic. Okay. Whether you want to permit the traffic or deny the traffic, you will decide that. And then after that, you will give the source IP address. Okay. And after that, you're going to provide the wildcard mask. This is how you're going to define your standard ACL, numbered standard ACL. Okay. So let's go and do the practical for this. So here I'm going to use a router. Even the router you can use as a PC. Okay. Means you can disable the routing features of your router and it will start acting as a PC. Okay. So how you can do that? Let's say I'm using these routers. Okay. So if this router I want to use as a PC, I'll just go to the global configuration mode. Okay. First of all, if I say do show IP route, because it is having the routing features, right? So I'll see that it is telling me about the codes as well as it is saying gateway of last resort is not set. But in case of PC, we are having the default gateway, right? So what I'll do, I'll say on the global configuration mode, no IP routing. And it will disable the routing features of your router. Okay. Now, if I say again, do show IP route, what it is saying, default gateway is not set and there is no routing protocol codes showing here. So means your PC router will be acting as a PC. Now, simply you can assign the IP address and set the default gateway and it will start acting as a PC. Okay. All right.
Default gateway is protocol we are not telling. Default gateway is not set.
Default gateway is not set means, let's say, why do you use the default gateway? To access another network, because default gateway is the exit point of your network. Okay. So if I want this router to act as a PC, to exit this network, it will have to go through this router. So I'll have to assign the IP of this router as a default gateway in this. Then only it will be able to exit the network, right? Clear? Any doubt? No? Online people? Okay. Similarly, on all three routers, you can do the same thing. Enable, configure terminal, no IP routing. And I'll say no IP routing. Now these are working as a PC. Also, this router I'll no IP routing. Okay, cannot use 4 interfaces. Okay, we'll consider this scenario. Now assign the IP addresses. So let's say here I'm going to use the network 192.168.10.0/24, 192.168.20.0/24. Now let's say this is 192.168.30.0. /20. Okay, and we are considering this is your PC1, PC2, PC3. Assign the IP address. So for assigning the IP address, I'll just use the notepad. I'll say enable configure terminal. Host name I'll set as PC1. Then I'll say interface the 0x0 IP address 192.168.10. Let's say 10 255.255.255.0. Let's say no shutdown. Configuration is done. Copy PC2. Let's say 20.20. PC3. Okay. Then on the router, so I'm going to say R1, enable configure terminal, host name I'll set R1, interface Z0x0, I'll say IP address 192.168.10.1, 255.255.255.0, no shutdown. Then interface Z0x1, IP address 192.168.20.1, 255.255.255.0, again no shut. Interface Z0x2, IP address 192.168.30.1, 255.255.255.0, and I'll say no shut. This is the entire configuration. Oh, 169. Okay, is it correct? All right. Copy this configuration, go to the router, CLI, and paste. Copy, go to the PC, paste. Okay, the configuration is done. Now, if you see, if I check here, the default gateway, show IP route, do. So right now, default gateway is not set because we have just set the IP address. Okay, so you say default interface. Oh, not interface. Just let me check once. IPv6. Yeah, IP default gateway. Okay, you are going to say in the global configuration mode, IP default gateway, and you give the IP address of the default gateway. So in case of PC1, that is 192.168.10.1. That's it. Now, if you check, do show IP route. So you'll see the default gateway is 10.1. Okay. Then go to the PC2 and set the default gateway. So exit, and you're going to say IP default gateway and 192.168.20.1. On PC3, exit IP default gateway, and you're going to say 192.168.30.1. Done. Now let's test connectivity with PC1, PC2, and PC3. So in the privilege mode, I'll say ping 192.168.20.20. Have the connectivity. Success rate is 100%, right? Similarly, go to the PC2 and okay, on the PC1 also test the connectivity with the PC3. So I'll say ping 192.168.30.30. 100% have the connectivity. Means PC1 is having connectivity with PC2 as well as PC3. Also, your PC2 is having the connectivity. Check ping 192.168.10.10. Have the connectivity. And 30.30. Have the connectivity. Okay. Now what we are going to do, our task will be filtering PC1 traffic with PC3. Means PC1 should not be able to communicate with PC3. This is our task. Okay. But your PC2 should be able to communicate with PC3. So to configure this, we are going to configure standard ACL, and the source will be your 10.10. Okay. So go to the router and create a standard ACL. In the global configuration mode, say the command access list, and you see you will have to give the number. So your packet tracer support only this range, 1 to 99. So for standard access list, the number is 1 to 99. I'm creating the first access list, so I'll say the 1. I'll say access list 1. Then I'll have to tell whether I want to deny or permit. So what I want to do, deny or permit. I want to deny the PC1 traffic with PC3. Okay. So I'll say I want to deny. Now, which address you want to match? See, there are 3 options. One is that you match the address, you say any, or you say a host. So when you are matching a single IP address, you can use the host directly. Okay. And for a single host, again, you can use this also. But when you are using the IP address to match, you have to give the wildcard also. And when you're giving the host, you don't have to give the wildcard. See, if I say host, and if I see here, I have to give the address. So let's say I'll give 192.168.10.10. But now I do not have to enter the wildcard. But instead of saying host, if I directly match the address 192.168.10.10, it will ask me for wildcard bits. Okay. So this is up to you. When you're matching a single host, you can directly use the word host and no need to give the wildcard. Okay. All right. Then there is one more word, any, means matching all the traffic, all the host, means this is going to block entire traffic. Okay. So right now I want to match a single host. So I'll say host, and what is the IP address? 192.168.10.10. Okay. Okay. I have created the access list. Right? You can check. Do show access list. So I have standard IP access list. Number is 1. And that access list is saying deny host 10.10, means deny the traffic from this host. But again, if I try to ping now from PC1 to PC3, I'm able to ping. Why? Because I have created the access list. I haven't applied it in an inbound or outbound direction. I haven't told my router that you should filter it when incoming or when outgoing. So tell me one thing. On this router, this is your router, right? R1. So on R1, on which interface the traffic will be incoming and which interface the traffic will be outgoing? Z0 by 0 incoming and Z0 by 2 outgoing. Means if I'm applying this ACL on Z0 by 0, I will have to apply it inbound. And if I'm applying it on Z0 by 2, I will have to apply it outbound. Okay, so which interface should we apply? Any interface you can choose. Okay, let's say I'm applying on Z0 by 0. But there will be a problem if I apply it on Z0 by 0. What will be the problem? It will not be able to ping even PC2. Because instantly at this interface, your router is going to drop the traffic. So which interface we should apply now? Z0 by 2. And in which direction? Out direction. Okay. So go to the Z0 by 2 interface. I'll say interface Z0 by 2. And then you are going to share the command access group. And then you have to give the ACL number. What is the number of the ACL? 1. So 1. And then you have to say inbound or outbound. Wait. IP access group 1. And which direction you want to apply? Outbound. Say out. Hit enter. Okay, now we'll try. PC1 is able to ping or not. Got the use. Okay. So it will not be able to, because the packets will be undeliverable. Because your router is not going to deliver the packets. Why? It is going to filter. So earlier when you saw on the router, if you see, when I checked the access list, there it was not showing any match, that no traffic matches this particular scenario. But now if I check, do show access list. How many matches were there? 5. Why 5 matches? Because your router, when tried to ping your PC3, how many packets it sent? 5 packets. And all those 5 packets were matched in the first access list and they were dropped. Clear? Okay. But again, there is a problem. What is the problem? If I go to PC1, I'm not able to ping 30.30. But what about 20.20? According to our configuration, we should be able to ping, right? We are able to ping. Correct? Any doubt? So if by mistake you apply it on this interface Z0 by 0, it is going to block PC2 as well as PC3. But again, still there is a problem. What is the problem? Did we configure any ACL for PC2? PC2 should be able to ping PC1 as well as PC3. Okay, let's check. So pinging PC1, We have the communication, but what about PC3? No. Why? We did not configure anything, right, about PC. The source was 10.10. But again,
Outgoing one.
yes, outgoing is good, but on the outgoing interface also we applied the ACL 1, right? And ACL 1 says, according to your ACL, only we denied the host 10.10. We did not deny the host 20.20. So what is the problem? The problem is with your access list, there is an implicit deny statement. Means there is a hidden deny statement, and that statement is saying deny from any host to any destination. I mean, deny any, not any. Whatever ACL you have applied, other than the ACL, deny all the traffic. Other than the ACL, deny all the traffic. This is what your ACL says. So this is the implicit deny statement that is available, that is hidden in your ACL. Okay, and in your CCNP, you are going to study like right now we are studying ACL, you will study route maps. There also the same thing. They will be having this deny statement. Okay. So there is an implicit deny statement. Now we have to permit rest of the traffic. We just want to deny this and we want to permit rest of the traffic. So what happens with your ACL? Whenever a traffic is coming, your ACL is matched in the sequence. First, it will be matched in the first line. If not matching, second line. If not matching, third line, like this. If it got a match at the first line itself, then it will not check the other lines. Okay. So now understand. To permit rest of the traffic, go back to the global configuration mode, hit the same command, access-list, the number is 1. And this time I want to permit all the traffic. So permit any. Hit enter. Now if I check again, do show access list. Now you see, I have a permit any statement. And below this permit any statement, I have a deny any statement. So now what will happen when PC1 is trying to send any traffic, that will be matched on this, correct? So it will be blocked. But when PC2 is trying to send a traffic, will it match in the first line? No. What about the second line? Permit all the traffic. So match here. So it is not going to check for the third line. Okay. So when we give this permit statement, now you'll check, you'll have the connectivity. Is it clear? Any doubt? Numbered standard ACL. So only one thing is there. This is the way to configure. And you must take a note here. At the end of every ACL, there is a implicit deny statement. So to permit rest of the traffic, we have to configure permit any statement. So always remember this thing. Otherwise, you'll end up having a problem. You'll see we haven't configured any rule like this blocking the traffic, but it is still blocked. Okay, because again, this implicit deny statement, this will not be visible in your configuration also. So even if you check the configuration, this will not be visible. And if this is not visible, you will have problem troubleshooting your network. Okay, so always remember this thing. Is it clear? How do you apply the ACL? So to apply the ACL in the global configuration mode, you go to the interface and the interface name and number. Like your interface Z0/0. After that, you say IP access group. Then here you will give the ACL number. And after that, you will specify whether you want to apply it inbound or outbound, the direction. Okay. Is it clear? Clear to everyone? Online people?
Yeah.
Okay. So this was the numbered standard ACL, means a way of configuring standard ACL. Now, second method is the named ACL. Okay, named standard ACL. Noted? Okay. There is no difference in the working of your named and numbered ACL. Just the difference is the configuration. Okay. So in named standard ACL, you use the name instead of a number. Okay. So how do you configure it? Again, in the global configuration mode. So the numbered ACL, you started with the command access list, right? The name you'll start with IP access list. This is the difference. IP access list. Then you will specify that you are using standard ACL. So you'll say standard, and then you'll give any name to this ACL. This name is completely your choice. You can give any name. Okay. After that, your prompt will change into config standard named ACL. And then you have to directly give whether you want to permit or deny. Okay. And then you'll give the source IP address, and you'll give the wildcard. Okay, this is the way. Applying this ACL is similar. How do you apply this ACL? That will remain similar. You'll say in the global configuration mode, you'll go to the interface name and number. And after that, you are going to give the same command, but instead of ACL number, we'll give name of ACL. You'll say IP access group, and instead of ACL number, we are going to give ACL name. And then whether you want to apply it inbound or outbound. Okay. So whatever task we performed, PC1 to PC3 we blocked. The same task we are going to do with the named ACL. So I'm going to remove the ACL. So to remove the ACL, I'll say no access list 1. That's it. If you check, do show access list, no ACL is present. Okay. And we applied on the interface Z0 by 0, right? Interface Z0 by 0. Oh, Z0 by 2 we applied outbound. And we set the command IP access group. Then we gave the number and we say out. This was the command we gave. To remove this command, I'll say no and enter. Now I do not have any ACL configuration. And you can check your PC1 will be able to ping 30.30. PC1 is able to ping the PC3, correct? Now we'll perform this task with the help of named ACL. So I'm going to say IP access list, and I'm configuring standard ACL. So I'll say standard. Now give any name. Let's say I'll give block PC1, PC3. Means with the name, I can know that for what purpose I'm creating this ACL. Okay. So I'll give this name and then I'll say deny, and deny which host I want to deny, 192.168.10.10. And I want to permit rest of the traffic. So I'll say permit any. This is my ACL configuration. Then apply it on the interface. I'll say interface Z0 by 2, and I'll say IP access group. Instead of ACL name, we have to give this name. So I'll just copy and paste this name. And I want to apply it outbound. That's it. This is the configuration. Now again, your PC1 will not be able to ping. And your PC2, because we have permitted rest of the traffic, will be able to ping. And if you check in the ACL, so before we were having the ACL, something like this, standard IP access list 1, and these are the entries. You check again, do show access list, standard IP access list, block PC1 with PC3. So I'll check the configuration. I'll know that this particular access list is blocking PC1 communication with PC3. But looking at the number, can I know what is happening? Can I know here for what purpose I'm using this ACL? This is just going to say, I want to deny this host. But why I want to deny, from where to where I want to deny, no information. But in case of named, you can have this information just looking at the name of the ACL. Okay, so you can configure the name in such a way that whenever you look the configuration again, you will already know that, okay, this particular configuration is for what purpose. Okay. Is it clear? Any doubt in the named standard and numbered standard? Means any doubt in the standard ACL? No? Clear to everyone? Online people?
No.
Okay. So standard is clear. Then we'll move to the extended ACL. So first of all, we'll see numbered extended ACL. Okay. So for this purpose, we are going to need different type of services also. So what I'm going to do, instead of routers, this time I'll use a server and a PCs, so that we can have, or let me just use, instead of PC3, I'll use a server, so that we can create a web server. And same IP address I'll assign here, 30.30, and gateway will be 192.168.30.1. Okay. All right. Check the communication. So we have blocked, so communication will not be there. So I'll remove the ACL entries. I'll say no IP access list and just paste the name. So many C. No IP access. Do show access list. Name is correct. No IP access list. Standard. Then the name. Okay. All right. So no configuration. Let me remove it from Z0/2 also. No IP access group. Paste the name and say out. Configuration is removed. So now your PC1 should be able to ping PC3. Able to ping? Correct? Okay. But to check the web server again, okay, we'll perform, instead of web server, we'll perform with the telnet. Okay. We'll see, we will block the telnet service and we'll allow the ping service. We'll do like this. Because in routers, we cannot see the website, right? So again, I'll have to use a PC for that. So instead of that, we are directly going to use router and we'll perform the practical with the telnet. Hostname PC3, interface Z0/0, IP address 192.168.30.30. I'll say no shutdown. Exit IP default gateway and 192.168.30.1. Check the communication. Have the communication. Okay. Now, first of all, what I'm going to do on PC3, I'm going to configure telnet. Okay. So to configure telnet, I'll say line VTY 021, password 123, and login. That's it. So now if I check on PC1, I'm able to ping. And if I check telnet, 192.168.30.30, asking for password, right? If I give the password, I have the PC3. Correct? So what we are going to do, we are going to block PC1 telnet with PC3, but PC1 should be able to ping. Only telnet we are going to block for PC1. Okay. All right. So you are going to configure it on the router. Go to the router and the command will be starting with access-list. Then we have to give the number. So what is the number for extended? 100 to 199. Okay. So let's say I'm giving it 100. Now you want to permit or deny? Deny. So say deny. Which type of protocol you want to deny? Telnet. And telnet works on which port number? 23. Which protocol? UDP. TCP. So I'll say TCP protocol I want to block. Okay. You see there are certain protocols, right? Then source address. Who is the source? 10.10 PC1. So only single host is there. So I'll say host. Now again, who is the destination? Again, destination is a single host, 30.30. So I'll say host 192.168.30.30. Now, which protocol you want to block? Port number 23 you want to block? So you say, you see this? Match only packets given on a particular port number. So you say EQ. Either you specify directly the port number or you can specify telnet. Up to you. If you say 23 also, that is fine. If you say telnet also, that is fine. So you want to block telnet only? Hit enter. Done. But again, implicit deny statement. So we'll have to permit rest of the traffic. How to permit rest of the traffic? Give the same command. Access-list 100. This time we want to permit, and we want to permit all the IP protocols, all the internet protocols. So I'll say IP from any source to any destination. From any source to any destination. Hit enter. Now check PC1. Okay, we haven't applied it on the interface. So which interface we should apply? Why Z0/2? Why not Z0/0? Why Z0/2 and why not Z0/0? Why? Because this time we have specified source as well as destination also. So your router is going to match if it is for which destination. So always remember your extended ACL, you always apply it closest to the source. in case of extended ACL, because you have specified source and destination both. So extended ACL you can apply close to the source, closest to the source. So who is the source? PC1. And what is the closest to the source? This is 0 by 0. And your standard ACL, you apply close to destination. So in case of standard, this was the destination. So you apply it here. Got it? Standard closest to the destination, extended closest to the source. So I'm going to apply it on Z0 by 0. You can apply it on Z0 by 2 also. There is no problem. Going to work the same, because this time we have both source and destination and protocol, everything. So your router is only going to filter that particular type of traffic. So I'll go to the interface Z0 by 0. I'll say IP access group, access list number is 100. Then which direction? Z0 by 0. Z0 by 0, which direction? Out. Out. Out or in? Out. Why out? Traffic is going from the PC. Yes. So if traffic is going from PC1 to PC3 on interface Z0 by 0 of the router, the traffic will be incoming or outgoing? Outgoing. How come outgoing?
Incoming to the router, but
Yes.
outgoing to the PC.
Yes, but configuring on router, right? So for router, it will be incoming or outgoing? Incoming. So you are going to configure it inbound, because the telnet traffic, your PC1 is going to make a telnet request, right? So it is going to come this side, and on interface Z0 by 0, this will be inbound. Okay. Hit enter. Now check. PC1, is it able to ping 192.168.30.30? Earlier, we were able to telnet. What about now? Telnet 192.168.30.30. Only trying. Will not be able to access. Clear? But what about your PC2? Enable configure terminal. Privilege mode. I'll say ping 192.168.30.30. Have connectivity. What about telnet? Got it? So we can block particular type of service or protocol with the help of extended ACL. And we can block entire traffic with the help of standard ACL. This is clear? Any doubt? All right. Now there's one more point, that your standard ACL, it blocks bi-directional communication. Means when we are blocking with the help of standard ACL, your PC1 to PC3, so PC1 will not be able to communicate with PC3. Also PC3 will not be able to communicate with PC1. Entire communication will be blocked. But in case of standard is in case of extended ACL, only one-way communication is blocked. If we are blocking from PC1 to PC3, then only PC1 to PC3 will be blocked. PC3 to PC1 will not be blocked. Okay. Let me show this example with the help of ping. This time, instead of telnet, we will be blocking ping traffic. Okay. So let me remove the configuration from the router. No access list. First of all, let me say, and then I'll say no access list 100. Check, do show access list. No access list is present. So this time your PC1 is able to take the telnet also. Correct. Exit. Now I'll block ping traffic from PC1 to PC3. Go to the router, create the access list. So access -list number will be 100. You want to block, so you'll say deny. Now which protocol you want to deny? Ping works on which protocol? ICMP. So this time we are going to say ICMP. Then from which host you want to block? 192.168.10.10 PC1 to the destination host 192.168.30.30. Now, what kind of message you want to block? You want to block ping reply, up to you. Right now we are trying to block the ping. I'm going to say echo. Remember ICMP echo message, ICMP echo request and reply. So we are blocking the request. If you say echo reply, your reply will be blocked. Okay, hit enter. Then to permit rest of the traffic, I'll say access-list 100. Permit all the IP protocols from any source to any destination. That's it. Now apply it on the interface. So interface Z0/0 IP access group 100 inbound or outbound? Inbound. Go to PC1 and try to ping. First of all, check the telnet. Able to telnet? Say exit, try to ping. Correct? Not pinging. But will your PC3 be able to ping PC1? It will be. Ping 192.168.10.10. Perfect communication. So in case of your extended ACL, only one-way communication is blocked. You can block one-way communication. Means let's say your server will be able to reach the clients, but the clients will not be able to reach the server. Okay. Is it clear? Any doubt? Online people? Guys, any doubt?
No.
No. Okay. So this is clear. Same task we are going to perform with the help of named method. So again, I'm going to remove the configuration. I'll say no, and then I'll say no access list 100. Configuration is removed. Check, do show access list. Whenever you are making changes in the configuration, always verify, because maybe sometimes you have given the command, but the configuration has not been removed, and you start doing the configuration again, and you will end up having two configurations or multiple configuration, and this is going to create issues. So whenever you are removing the configuration, changing the configuration, always keep on checking whether the configuration effect is taking place or not. Okay. This is one way of already troubleshooting your network, that whatever changes you are making, are those changes being applied or not? Okay. So for numbered extended ACL in the global configuration mode, we said access -list. You gave the number from 100 to 199. Then you said permit or deny. Then you gave the protocol. After that, you gave the source. And then you gave the wildcard. Okay, right now we haven't given the wildcard because we use the word host. We are having only single host, so we didn't use the wildcard. But if you are blocking an entire network, then you will be using the source IP address, network ID, and wildcard mask. Okay. Then destination, IP address, and after that, wildcard mask. So this is the configuration for your numbered extended ACL. To apply this ACL, go to the interface, interface name and number. And say IP access group, ACL number, and then whether you want to apply it inbound or outbound. Okay. Next we have named method. So let's perform this task with the help of named method. So in the named method, we start the command with the IP. Instead of directly saying access list, we say IP access list. So I'm going to say IP access list. This time we are creating extended. So I'm going to say extended and give the name. Let's say I want to block ping from PC1 to PC3. Okay, you can give the name that I have blocked the ping traffic. Now let me say block. Now it is more specific. Hit enter. Then you want to permit or deny. So first of all, we want to deny which protocol? ICMP. We want to deny the ICMP protocol. From which host? 192.168.10.10 to the host 192.168.30.30. So command will be same. The difference is that every time you don't have to say this thing access list 100, access list 100. You don't have to say this thing again and again. You will directly start your statement with the deny or permit. Okay. And then which type of traffic we want to block? Echo traffic, ping traffic. Then to permit rest of the traffic, permit IP, any and any. See, instead of saying it again, here we had to say it again. Access list 100. But this time I directly gave. Okay. Exit. After that, go on the interface Z0/0, IP, access group. Then the ACL name we have to provide. Copy, paste, and then inbound. That's it. Okay. Now check. What did I close? Okay. Configuration is done. Go to PC1. First of all, check the telnet access. Able to telnet. And check the ping. Ping 192.168.30.30. not able to reach. What about your PC3? Able to reach. And your PC2, it will be able to reach your PC1 as well as PC3. Ping 192.168.10.10, able to reach. 30.30, able to reach. And also telnet 30.30. Is it clear? So this is your named extended ACL. So we'll be saying IP access list, then you'll say extended, then the ACL name you will provide. After this, your prompt will change to configure extended named ACL. Here you will say directly permit or deny statement. Then you will give the protocol. After the protocol, you will give the source IP address, the wildcard, then the destination IP address, and then again the wildcard. Okay. To apply it on the interface, you will go to the global configuration mode. Then you'll say interface name and number. And after that, you'll say IP access group. Then you'll give the ACL name and you'll say either inbound or outbound. This is your named extended ACL. So any doubt with the ACL? No? No doubts. Clear or very clear?
Need practice.
Need practice.
Yes.
Okay.
Sir, when doing this configuration in the lab,
Yes, you can do this configuration in the lab. Same scenario, you see. In your lab, we are having 4 routers and 4 switches, right? They are connected to each other. So you can see right now we are just using 4 routers only. So you can have this configuration. Okay, you can do this configuration in the lab with the 4 routers. And you can check, yes.
So for example, if we have to block a particular network, then what would be the IP address? Would it be the
Network ID. No. The network ID. Let's say I want to block this entire 20 network. So instead of saying host 10.10, I'll say 192.168.20.0 and the wildcard will be 000.255. That's it. Then again, if the destination is single, then host and destination address. And if the destination is also a network, again the network ID and the wildcard.
Sorry, sir, I don't get that.
See, let's say I want to block the entire 10 network with 30 network. So my access list command would be something like, I would say access list 100, deny, and let's say I want to deny again ICMP, let's say, for example. From which network? 192.168.10.0, wildcard would be 255 to the network 30.0, 255, and I would say, let's say echo. So this one, this is your source, and this one, this is your destination.
it will extended access list of more than 1300. We need to do in DNS.
Yeah, about 1300. Yes, there is extended range for your extended ACL also. So standard range is 0 to 100, 199, 100 to 199. And in this also extended range is 2000 to 2699. If you use these numbers, your ACL will become extended ACL. Okay, your packet tracer does not support, but if you check in the GNS3, GNS3, yeah, will be available. Okay, let's say I'm having this router, so I'll turn it on. This is using real router IO, so it takes some time to boot up because real routers are not like a packet tracer. Okay, like going in on and off in 1 second, 2 seconds. So if I go to the global configuration mode, okay, you are going to see, I'll say access hyphen list. And these are the ranges of different type of ACL. Okay. These are the ranges for different types of ACL. So this is your standard access list range 1 to 99. Then again extended. Then the extended range for standard access. For standard list, this is the expanded range. And again for your extended list, this is the expanded range. Okay. So right now you don't need to worry about this. You can just go and work with this. Your CCNP will be having these two ranges. And there will be no difference, just the number. Instead of 1 to 99, if you put 1300, this will become again standard access list only. Okay, just the number is different, so that you can configure more number of access lists. That's it. And even in one list, you can configure multiple entries, right? Different entries you can configure. You can block different networks, different traffics in one access list. Okay.
This numbering just to extend more access.
Yeah, number of access list if you want to increase. Let's say I want to block different types of traffic. So let's say if I'm blocking PC1 to PC3. Okay, so I created one access list and I named it that this is for PC1 to PC3. Now second time I want to block PC2 to PC3. So I'll create new access list, so that whenever I have to edit the access list, add or remove the access list, it will be easy for me. Just looking at the configuration, I can remove a particular type of ACL instead of editing the existing ACL. Okay, in your CCNP, you'll see you can edit the existing ACL also. Okay, right now, if you notice here, when you check the access list, if I say do show access list, so you see these numbers, sequence numbers, 10 and 20, these are increasing in the difference of 10. So if you have to add an entry, you can manually add a sequence number between 10 and 20, and that particular access list will be coming in between these, between 10 and 20. Okay, means you can modify your access list. Okay, and this is possible in the named method only, not in the numbered method. If you see here, if I say IP access list, okay, extended, copy, paste, hit enter. If I hit question mark, you see I can already give the sequence number. So before permitting, let's say before permitting any type of traffic, I want to block telnet access of PC2 with PC3. So what I can say, I have to add it before 20, because if I'll add default case, it will become 30. Okay, let me just first add default and then I'll show you. Let's say I want to block, so I'll say deny telnet access I want to block. So TCP protocol, correct? From which host? 192.168.20.20 PC2 to PC3. 30.30 equal to telnet. Done. Now if I check, do show access list. What is the number? Now my router is going to match the ACL. First this. First of all, it will going to match this line, then this, and then the third line. Correct. So when I'm trying to take telnet access from PC2, it is going to first match here. So it will not match. Okay. Go to the second. Already matched because we have allowed everything. Okay. So your router will never check this thing, even if you have this entry. So anyhow, we have to bring this entry before this. So we are going to change the sequence number. Okay. And how you can do that? Let me do one thing. I'll say, first of all, I'll say no. Then instead of no, I'll say sequence number 15. That's it. Now, if you check do show access list, now your router is going to check, correct? So is it going to block the telnet access? Yes or no? Yes. Yes or no? Tell me. How many of you say yes, it will be blocked? And how many of you say it will not be blocked? We have done the configuration. Yes. You have seen the access list. Access list order is correct. If you want to check again, I can show you again. There's no problem. This is our access list. Interface. Okay, the interface. We have applied this ACL on interface Z0/0. And your PC2 traffic will never go to the interface Z0/0. So it will not be blocked. Your PC2 will be able to access. Okay, so means this time now we have to apply it outbound on the interface Z0/2, because this is the interface where PC1 traffic as well as PC2 traffic, both traffics will be coming, right? So let me go to the interface. First of all, interface Z0/0, no IP, access group, paste, and inbound. interface Z0/2, and this time IP access group paste and output. Now check. Not accessing. And what about your PC1? Is it pinging? Ping 192.168.30.30. Not pinging. So this way you can have multiple access, multiple entries in your single ACL, and you can block multiple type of traffic. We block telnet from PC2 to PC3. We block ping from PC1 to PC3. This is clear?
So is it only to block the protocols, or for example, sometimes in an organization we used to block the websites and all.
So block website HTTP protocol you block, HTTPS you block. They will be blocked.
Okay.
Because again your websites are working on some sort of protocol only, HTTP, HTTPS.
But if you block that, the entire HTTP will be blocked.
Yes.
So there is nothing. So for that.
See, this is just setting up the rules. We cannot block a particular website using this thing. Okay. This is just filtering network traffic. We are not filtering websites. Okay. Is it clear? For those purposes, we have different, like you can say firewalls. You have the firewalls where you can block them. This is clear. Now we'll see the differences between standard and extended ACL. Okay, the first difference, the standard access list number is 1 to 99. Agree? Extended access list number is 100 to 199. This is also agreed. Okay. Then with the help of standard access list, you can block a network, a host, or a subnet. We can block because we are blocking on the basis of source IP address. So the source IP can be a network, can be a subnet, or can be a single host. So we can block them. But with the help of extended access list, again, you can block this same thing. Okay. But again, one more thing will be there, the service. In case of extended access list, there will be this service also blocked. Means you can block a telnet service, ping service, ICMP service, protocols you can block. In case of your standard access list, two-way communication is blocked, stopped. And in case of extended, one-way communication is stopped. This is clear. In case of standard access list, entire communication is blocked, means all services are blocked. But in case of extended, we can block certain selected services. Is it clear? Then your standard access list, it is implemented closest to the destination. And your extended, it is implemented closest to the source. In case of your standard access list, the filtering is done on the basis of only source IP address. When we configure standard access list, we never specify any destination, any protocol, nothing. We just say permit this or block this, that's it. But in case of your extended access list, you can block on the basis of source, destination, protocol, and port number. All the differences are clear. Any doubt in any difference? No? Okay. And clear with the expanded range, 1300 to 1999 for standard and 2000 to 2699 for extended. So this is clear. I think that's enough for today. Yes. ACL can be layer 3. Let's check. Because for filtering network traffic, you must understand the IP addresses. Right? So your layer 2 switch, does it understand IP address? No, right? Okay, let's say 1. Okay, there is the option you have. Okay, I'll check on this and let you know. Because your switch does not understand IP addresses. Okay, so I need to check on this.
But it has MAC table, right?
Yeah, MAC table it has.
It has IP address and MAC table.
No. MAC table having the entry for port and MAC address. Switch makes forwarding decision on the basis of port and MAC address. Okay, so I'll check on this, whether it is applicable in layer 2 or not. Okay, and I'll let you know. Any other difference? Any more doubts? No?
So you were to say that why we are using D in EIGRP?
Yes. Why we are using D in EIGRP? That was a question, right? How many of you did the research? You did yesterday, I know. Other than any more students who did the research why in EIGRP we use D, why not E? Not that deep. So what you came to know? What was the thing you came to know about that?
It was a dual, and used for both interior and exterior.
So according to the algorithm, you are saying that according to the algorithm, it was given D. Then why not Dijkstra's algorithm, OSPF? Why not D again? Why not H in the RIP or B in the RIP, Bellman-Ford algorithm? These names were assigned because based on the protocol names only. Your RIP is having R, your OSPF is having O, your static is having S. But your EIGRP is having D, not E, because your E was reserved for the EGP protocol. There was a protocol EGP. Yes. So it was reserved for that particular protocol. And that time EIGRP was not there. Okay. So that time IGRP was there. Then IGRP got enhanced into EIGRP. But that time already the E word was reserved. So they came up with a D. D was free, no protocol with the name D. So they came up with a D. No, then they came to the decision, okay, this is a dual algorithm also. Instead of giving F, we can give the D. Otherwise, they could have given the F also, but they came up with a D. Okay, so that it could be having a kind of match thing. Is it clear? Okay, any students, new students who joined after the attendance?